Hi, welcome to Layer 1 2012. How many of you is this your first Layer 1? Wow.
Whoa!
That's awesome. How many of you is this your first security conference ever? Okay, that's good. It'll ease you in so that when you go to DEF CON you won't feel so degraded and used. But welcome. We hope you enjoy this weekend. A lot of people put a lot of work into it, such as this fine man, John Norman / ArcLight. And he's going to be talking to you about open source physical security. Before we begin, for those of you wondering, your parking is validated. We have a machine somewhere. Ask at registration.
You actually put your ATM card in it. Legit.
And and so that's covered. We have in the first room next to us, there's hardware hacking as well as a number of vendors. After that's obviously registration and food and beverage. And then after that is Tamper Evident Contest and Lockpicking Village. For those of you who are asking, are there any spots left on Tamper Evident? After this talk, which will be 11:30, if there's still boxes left, it's open to whoever wants to pick them up. So if you're still looking to compete in the contest, after this talk, come see me, and we'll see what we can do. And if there's a number of you, I would suggest forming a team, because it's a lot of work for one person. You ready?
Just a bet. I was gonna...
Anyways, John Norman.
So, since you mentioned putting your card in things, this is my slide for It's Totally Legit. Speaking of that, you might want to take this opportunity to turn off the Wi-Fi and Bluetooth on all of your devices for the rest of the con. I'm just saying, you know, it's not strictly necessary, but yeah, it is actually. As opposed to DEF CON where you just leave that in the car with the battery somewhere else. So my name is ArcLight, or John, and I'm going to talk to you today about physical security. And we're talking about electronic devices, access control, alarms, that sort of thing. And my background, I'm not an alarm or security guy. I'm just a guy. We wanted to have an audited electronic access control system at our hackerspace, which some of y'all, hopefully all of you, will be at on Sunday, 23B Shop. We're gonna have our after party there. So I guess we should start off with how many of you guys have interacted with one of these? If you used have a badge reader at work and all that kind of thing. You ever wondered what kind of goes on behind the scenes? You know, enough people mess with their keys and door locks and all the lock sport stuff. So we found out this stuff is rather a black box. So what this is about, physical security, we're talking people, assets, equipment, buildings, electronic locks and access control systems, intrusion detection, and alarm technology. What this is mostly not about are mechanical locks. All of these systems do have that as I guess you could say, an enabling technology. You do need to have a somewhat secure physical lock and strong doors and things like that if you expect these systems to perform. The network and information system security, that's also a foundation. Almost all of our alarms and access control stuff are eventually going to be talking over a network to a server or notifying people or whatever. So that's important, but also a totally different subject that is subject of other talks. Video surveillance. I recently went to, I believe it's the largest physical security convention at least in the US. It's called ISC West in Vegas. And what I found interesting was that it was basically all about cameras, and more cameras. Everyone seems to think that will solve all their problems. If we just have everybody watching everybody else, and maybe some cameras watching the cameras, and people watching the cameras, that makes all of our security problems go away. While that is an important technology in the right use case and tied in with other things like access control and auditing and so forth, it's actually kind of a crummy deterrent according to a lot of studies, and it really only solves a limited part of the problem. And then security policy development. Ultimately, all this stuff is to support some kind of policy. If you don't have a sane policy, though, it doesn't really help. Okay, so why we're doing this? This technology, as I started doing some research about 2 years ago, trying to install something, I found out that these are pretty much all universally closed source and mostly proprietary technology. All the vendors basically will tell you that their stuff isn't vulnerable because nobody knows how to hack it, which we know from the computer security world that works, right? It's made of magic, you know. As long as no one finds out what the magic is, it's safe. And yeah, okay, but you know, the magic always gets out, right? So really, it's kind of hard to find out what's going on under the covers. And I did, doing enough research and diving in, discovered a few things like it's pretty hard to make a real risk-benefit analysis. You can at least decide whether you want to buy a better door lock that's harder to pick, or protect your asset some other way. But it's kind of hard to tell because all these things have wires and little black boxes, and they may or may not do anything right inside. So I'm going to take a quick trip through sort of security theory 101. Start off with what is security? In this context, we're not talking SQL injection. We're not talking about getting your credit card database pwned. We're talking about your actual stuff. So really, we have assets, and that could be everything from, it could be hard drives full of intellectual property. It could be people. It could be your facility. In our case, it's our hackerspace, and we wanted to keep the junkies that hang out in the alley outside of it, and us inside, generally on the other side of the perimeter, whenever possible. And most of our stuff, not at the pawn shop. So threats to those assets, you have different kinds of threat actors or people that, in this case, we're saying intentionally want to get at your assets in a way that's not authorized. And then, the type of countermeasures you can bring out. So when we talk countermeasures, right, what are those? Well, we're talking about things like the locks, the alarm system, the notification, the auditing, all that stuff. And all those things have, different aspects to them. You can increase security. You may very well, with a countermeasure you deploy, break something else. You might decrease security in some other area or safety. You could put a really awesome door lock on your front door, but if it takes a 4-step process to exit, you might die in a fire. So there are regulations and things around this, and the manufacturers of these have been working on this for a long time to make that, at least the physical part of it, work pretty well. But the electronic part, it's kind of hard to say. If I plug this thing into the internet to plug in, there's actually a cloud access control service. You put these little boxes on your doors, and then you connect to a cloud app. I'm not kidding, it's out there. Do they tell you anything about what what additional vulnerabilities you open up while adding these cool features? They really don't, right? So, what it comes down to, it's always a trade-off. Cost, right? This stuff can be very expensive to, really expensive. Convenience, that's actually a good thing. We typically talk about security or convenience, right? Having the, how many people have a really dreadful policy or password policy at their work? It has to be complicated, it has to be changed all the time. And so what do people do, right? They write it down, it's on a Post-it note on the bottom of their laptop or something like that. One thing I found out with this type of technology, if it's done right, convenience and security can actually go hand in hand. Like if you make it convenient to lock up the door that goes out to the sketchy back alley every time, nobody props it open. If it closes on its own and beeps and locks, and people feel safer because they know when they're there alone, the default is that that's not happening, but they can easily walk in and out almost unimpeded, they actually will follow the security policy better. I mean, I think the biggest threat to, say, data center and other kinds of facilities like that in terms of security, smokers, right? Everybody has, almost every developed country has some kind of no smoking inside policy. So where does everyone go? They end up outside in the back with the door propped open. Well, this kind of stuff can, maybe they should have some sane policy, like a place to do that and not encourage you to do that, but you can do things like set up alarms and alerts if the door is propped for too long and stuff like that. So this is kind of an interesting thing. I actually found this in a physical security book called Electronic Access Control by a guy named Thomas L. Norman, and he's been doing this for a long time. But the 3 categories of people in your site, those who support the mission inherently, and those would be like the founders, homeowner, someone who has a vested interest, the partner in your business, and you, whatever it may be, relatively small group that maybe they aren't 100.0% trustworthy, but they're as close as you'll ever get to it because their interests are very much aligned with the interests of what's going on, the mission of your site. You have people who straight up oppose your mission, and those could be competitors, people who are just straight up thieves who want to steal your computers or break into your stuff or rob your employees, or if it's a store or whatever it may be. And then they're a fairly small group of people. And then you have everybody else, which would be those who sometimes support and sometimes oppose the mission. Those would be like employees, contractors, guests, visitors. And really, all three of these groups have different needs. So core users, supporters of the mission, right? They have the same safety and security goals as everybody else that's authorized to be in your building. We want to protect them from perhaps outsider threats, perhaps from fire and theft and things like that to the extent we can. The people who are responsible for this obviously want to take care of their assets and their people, and then they are going to want to be able to manage this. So be able to tell who has keys to what, be able to revoke those or issue those, and have an idea. Some places also do things like visitor management, know who's in your building in case there's a fire, let's say, did everyone get out safely, stuff like that. Our criminals, outsider threats, that's pretty much what we always talk about when we're talking about IT security. That's pretty awesome. We have an outside, pretty clearly defined perimeter in the case of a building. A little different if you're a cloud application provider, it's where's your perimeter? But this is pretty obvious, right? You're either on property or not. And there are people who we just clearly don't want there, and we want to discourage them. We want to increase the risk associated with their, bad actor activities like stealing your stuff or threatening your employees. And then everybody else, right? So, that's mostly about managing inside threats, visitors, contractors, the pizza guy. I kind of like that. Every place that has a PIN reader out front, apartment complex, even some pretty high security facilities I've been to, it seems like the pizza guy, or even worse, I went to a data center a while back that had a door hanger from the Thai restaurant guy. You need a handprint reader to get into that place. Those guys are ninjas, right? And people think that pizza delivery is critical enough to the mission that guy needs the code to get in. And so you want to be able to do things like find out who let whom in, have access logs, maybe video, maybe be able to verify what happened when. That's basically a function of auditing. It has some deterrence, but it's basically about finding out what happened after the fact. And then a really important thing is being able to issue and revoke keys and make those keys possibly have a finite life cycle. You issue a metal key, and it's basically there forever until you change the locks or you try and get the key back. How many people want to deal with getting keys back from hackers who moved out of state 2 years ago, right? It's not going to happen. And if you're running a for-profit business, that's 10x full, right? So what do you have here? We really perform 4 basic tasks with these kind of electronic security systems. For those outsider threats and to varying degrees the other inside players, we really want to deter, detect, delay, and respond. There's no such thing as perfect security. The manufacturer's literature for all this stuff, some of them will talk about everything end to end over every piece of copper is AES 128 encrypted. Well, it doesn't really talk about some of the other things like do they use the same key in every device that they send out. But also, they don't really give you a complete picture. The fact that you're going to put this perhaps even provably audited security device that passes some government or GSA or FIP standard on your drywall partition data center, maybe it's a waste of money. Maybe you should have spent some money hiring a contractor to build a solid wall and put a good door in before you spent all that money. So really, any number of people can break into stuff. All you're really going to be able to do is try and detect them, delay them, so that you can get a response from your staff, the police, whatever it may be. And we want to enforce a security policy at the end of the day by doing that. So I'm going to take you through, this is kind of an interesting model. This is in, have any of you guys read Ross Anderson's Security Engineering? Have you seen that book? I'll have links at the end of this, but I highly recommend that. It's a weighty tome. It's about 1,000 pages. The second edition is like your typical expensive tech book. But he did something really cool. He is a professor at, I think he's at Cambridge, and he put the first edition online as a free PDF download. And it's very good. It covers all kinds of things like database and network security, app security, and it covers physical security and even things like how nuclear weapons are secured. So he has a really interesting approach to all this stuff where they try and do threat modeling. They want to make this a little bit measured, a little bit more rigorous. And we're starting to do that. We're using mathematical models, much more security, and trying to prove all the test cases and does this or does this not sanitize the input data and so forth. Well, he has a whole chapter just trying to apply that to physical security. And so he comes up with these 4 model attackers, which I think came from some Army program years ago where they tried to figure this out. So the first one is Derek. Derek is a 19-year-old addict. He's looking for a low-risk opportunity to steal something he can sell for his next fix. That would be some of our neighbors at the shop. Charlie X, is a 40-year-old inadequate with 7 convictions for burglary. He spent 17 of the last 25 years in prison. Although not very intelligent, he is cunning and experienced. He has picked up a lot of lore during his spells inside. He steals from small shops and suburban houses, taking whatever he thinks he can sell to local fences. Bruno is not the Ali G Bruno, but Bruno is a gentleman criminal. His business is mostly stealing art. As a cover, he runs a small art gallery. He has a Ford's University degree in art history on the wall and conviction for robbery 18 years ago. After 2 years in jail, he changed his name and moved to a different part of the country. He has done occasional black bag jobs for intelligence agencies who know his past. He would like to get into computer crime, but the most he's done so far is stripping 100K worth of memory from chips from a university's PC back in the 90s when there's a memory shortage. And then we have our top shelf threat actor, Abdurrahman. Abdurrahman heads a cell of a dozen militants, mostly with military training. They have infantry weapons and explosives with PhD-grade technical support provided by a disreputable country's university. Abdurrahman himself came out 3rd of a class of 280 at the military academy of that country, but was not promoted because he's from the wrong ethnic group. He thinks of himself as a good man rather than a bad man, and unfortunately his mission is to steal plutonium. So, how do we deal with these? So your typical commercial business space, which, mind you, going through all the security catalogs, they talk about their good, better, best products. All of the products pretty much used in residential situations are all in the not good. Just basic things like the locks, the doors, etc. They're all the type that are not recommended for commercial applications just because they're not abuse resistant and they don't support some of the more secure stuff like some of the electrified hardware, putting the better high security lock cylinders in. You typically are going to have 5, 6, or 7 pin mortise lock, some tempered glass windows, and maybe a basic alarm system that people may or may not use consistently. I mean, how many people have had a job where they gave you an alarm code? Ever had to deal with that? And you come in and they scribbled some instructions that said, oh, it's so simple. After it starts beeping, hit star pound, star pound, command 7, your pin is followed by star pound. Why do you keep setting it off? I think you're stupid, right? So what do you do, right? After the second time that happens, you just don't set it anymore unless the boss is around. Or you just make sure you're never the first one to come in or last one to leave because it sucks. So these things are maybe deployed, 50% of the time properly, if that. That's probably on a good day. Larger sites may have their own on-site security staff, which vary definitely in grade, just like our attackers. We have everything from TSA to good security. Ooh, burn. Better locks. If nothing else, commercial sites are usually forced. Large institutions are forced to buy quality hardware because the number of people opening, closing the doors, and banging on it, 8 to 12 to 24 hours a day is just, you can't buy cheap stuff, it'll just wear out. The better stuff tends to be more secure, and they tend to do things like pass the angry man test, where you can kick on it and hit it with your fists as long as you want, and nothing will really happen. You at least need 1 or 2 guys with decent tools and a little time to break into it. Whereas if you take the angry man test, there's the shining guy outside your apartment. I mean, how many residential doors and windows and so forth would survive that for more than seconds or maybe a minute, right? Versus, say, the door to a library or a school, you would hurt your hand, right? So it's one way of thinking about that. Really, your typical commercial space, the access control, or which is probably just provided by metal keys, the alarm system, so forth. That's targeted at your Derek and Charlie model attackers. Places like a properly run data center, high-value sites that handle money, valuables, equipment. They also attempt to delay a more sophisticated attacker like the Bruno guy. And he can do things perhaps like hire a cleaner to get into your staff, or reprogram your alarm by buying the identical alarm and program it to accept every key. Someone like that, if they really wanted your stuff, would probably get in, or they would do something like rent some demolition tools and cut through your wall. And all you can really do is delay that person and make it harder. Aside from the with or without tools kind of attack, all this stuff is rated by UL, and there's some ANSI standards for basically how long it'll resist someone with no tools, with tools, two people with different tools, so forth. None of these claim to have actual protection. They're only a delaying measure. And when our last attacker, really our top shelf threat, our guy who's stealing the plutonium, he's realistically a problem for the military. What you use to stop people like that would be mass. Mass stops things like explosives and small arms and chainsaws with carbide blades and things like that, and infantry people with guns. You have really high security facilities. I think the best designed ones, in fact, are the ones that don't look like there's anything going on, like an embassy.
Or a sign in the window that says, "We have no plutonium."
That could work. Kind of like the no radio sign you put in your window in New York. But really, yeah, these kind of people, you ever look at something interesting? The Crown Jewels in England, they have this little low building, and they put you on a conveyor belt, and it's just regular like library cases with just glass. It looks like regular glass, although it's a little thicker. And it looks like nothing's going on, although if you were to heft one of the doors, you notice it's really well balanced, but like you tap it and it feels like it's made of something very, very solid. And then you notice there's an infantry garrison right next door, and there's planters and things around, but they're solid reinforced concrete with railroad posts and things in them. Those little subtle security features, they're big deployable barriers in all the entrances and exits and stuff that aren't obvious. And they're trying to to delay and inconvenience a top shelf attacker. And those other kinds of sites, they'll have a combination of visible and not visible measures. But really, all they're trying to do is delay that kind of person until in their case, the Marine detachment comes out with all their weapons and kills them. That's their idea. We're just trying to call the police, probably. So, typical features of one of these systems. There's normally a module, looks similar to this. This is my system, but it's kind of a loose collection of a bunch of different commercial systems and what have you. Typically control between 1 and 4 doors, almost never more than that. The cabling runs, unlike networking where 100 meters is no problem. You're running actual power to manipulate a physical device, so they can only go so far without having a power supply nearby. They may be controlled locally with some intelligence in the firmware. They may be like a small appliance, or they may report back to a client server app. There's typically, unfortunately, a Windows-only workstation that, if you're lucky, maybe some of the systems have a web app for managing it. You typically have some type of electric locks on the perimeter and or suite doors to your offices, things like that. And I'm going to go into those. You have some kind of access token readers. See that okay, guys? You have things like cards. Those would be contact or contactless. They have their own different security issues. PIN readers, biometrics, other kinds of technologies. One of the key features is that you have to have some kind of exit device. Everywhere that is in the path between you and outside the building has to have an easy way for everyone inside the building to get out in case of an emergency. And that's fire, generally, is the first thing people think of. But it could also be other things. If there's someone shooting up your place, one of the few of the studies have shown that one of the best responses in many cases is to put distance, and get away from those people. The lockdown idea isn't always a good thing. So typically exit paths, not necessarily coming back in, but exiting is generally something you don't want impeded for almost any reason. They say that a typical test is, can a person with no special knowledge, get out, open this door and get out. So that includes things like panic bars, handles, doorknobs, stuff that people just inherently know how to use in almost every place that has buildings and walls. Sometimes a push to exit device. Motion detectors, we'll talk about those, but that's one of my favorite, especially when they're double glass doors and a motion sensor that unlocks them on the way out. One of the things these typically do, which maybe isn't obvious if you haven't been on the other side of building one of these systems, the push to exit device, the motion detector that lets you out, things like that, or sometimes the doorknob itself, typically send a signal to that access control panel to suppress the alarm that this door got opened. So they're basically saying this was a legitimate activity because somebody without a key was coming from the inside to out, which we allow. So don't alert security or set off the alarm. Now that's in some ways a vulnerability, right? Because it's, can you trick it into doing that, when you're coming on the way in? Maybe. You typically also have some integration if it's a larger system where it can do things like trigger an event in the event log for your video system. The fancier systems, when someone comes or goes, it'll bring up on the screen, let's say the camera that shows the hallway of who just walked in, or if there's a visitor at the gate, that sort of thing. Typically do things like suppress the alarm system. A lot of them have integration. Those don't have to be even logical integration via code and APIs. They may just have like a dry contact from a relay. And maybe it goes to an input and the alarm system is wired to say, if you see this input, do this or don't do this, set off the alarm, don't set off the alarm. A common one with fire alarms is that if it's exit door, they want the local inspectors who control this, they call it the AHJ, the agency having jurisdiction, wherever you happen to be in the US, they may ask that your access control system open all of the doors to inside and outside access if there's a fire. So that definitely is a security issue. It's also an issue of safety, though, if they think that it would be a lot easier for the fire department to get in. So it's kind of a trade-off. That seems to make more sense if you have somebody on site who can watch the store while that happens. If it's a completely lights-out data center, I don't know. That may or may not be what you would desire. One of the other cool things the fancier systems can do is tie in with like building controls, like heating, ventilation. It can turn on the air conditioning in your floor or your office. For safety, it can do some cool things like light up, like if you badge in the parking lot, it can turn on a path of lights all the way from your car to your office. So it's a little safer and kind of discourages bad behavior. So this is probably going to be a little bit hard to see, but your typical system is going to have over on the left these distributed access panels. A door sensor, detect the position of the door, request to exit sensor, know when someone asked to be let out or pulled the handle and told the system essentially that they're leaving. Some type of access reader. These may be in different floors all over a building, all out in a campus. They will get back to some kind of panel that supervises them, where they typically will go to Ethernet at some point. There may be RS-45 in a local network. When it gets to a large campus, it's almost certainly going to be Ethernet tie-ins, at least back to after they get to the wiring closets, that kind of place. So here are a few things. These would be kind of rundown of the locking hardware. What is this stuff controlling? We talk about, at the end of the day, this is just a fancy device that accepts some signals and opens or closes a relay. So the electronics are a little bit hard to get right, but they aren't anything amazing that hasn't been done for like 30 years. So, they're controlling devices like, we just call it electrified hardware. Not electrified in the sense of shocking people, but electrified in the sense of there's some kind of electromagnetic device that, manipulates pulls a pin out or unlocks a cam, something like that. So the first choice, if you have commercial doors or you can put one in, mortise locks. They're embedded inside basically a pocket that's machined out of the door, wood or metal doors. They have what's called a dead latch. It's not exactly a deadbolt like a Schlage deadbolt